Hello and welcome to another video from Ellensburg Amplifier Repair and Service. My name is Todd, and what we're going to be going over today is an MMats Pro Audio SQ 4-channel amplifier. It says revision 5 on it. I don't know what amplifier this is. Over here it says SQ 4000 0.3. Well, this is a 4-channel amp, so I don't know exactly what this is. It doesn't say anything on the case or on the cover. It just says MMats Pro Audio. This is a customer repair. This is private repair, and I got this in, and it had a broken switch, so it took me a while to locate a switch, which is just behind the meter here, this switch right here. It was broke during shipment, so it took me a little time to find a replacement for that switch. I did find a replacement. It's got a little slightly smaller handle than the original, but it came from a Rockford Fosgate crossover board. So I got that switch replaced. It's on full pass right now. I've got my 50 Hertz input signal here, and now I'm going to show you how I go about finding the issues on boards here. So my power supply, as you can see right here, the ground, the negative, I shouldn't say negative, the ground of the 12 volts is grounded to my scope. So I've been getting some questions on grounding. It's a really common question on scope grounding. Here's my probe. I do not use the clip to clip onto the amplifier itself, because I ground the scope itself to my power source, because this is a isolated power supply that I use. So it's grounded here to the scope. Which allows me to not have to worry about having a separate lead on the scope end itself. You'll get these leads like this that clip on to the probe, which you can then ground around where you want. But be aware, you connect this to the wrong place and you could damage your oscilloscope. It's always best just to ground your isolated supply to your scope and leave your probe end open. That way there's no issues on grounding. And then always make sure your probe is set to 10x and not 1, because amplifiers of course have high voltage. So hopefully that covers some scope grounding questions for you. On supplies that are not isolated, that are grounded through earth ground, well, your scope is already grounded through the 3 prongs, going through your household wiring, going back to your like a regulated power supply. My PS50 is grounded. My 50 amp supply is grounded, so I don't have to worry about running a ground lead from the ground of the 12 volts to what I'm working on, or to the scope. So let's go ahead and fire up this board. I did power this up previously. It had quite the whine to the transformer, which is real common for older boards, is to get that whine. And these SG3525s I've noticed has more whine than like a TL494 or a 594. So I'm not sure if you can see it, but right here I did add some of my good old infamous glue. So when I powered the power supply up, it had a whine, and I would twist the transformer to a point where it was quiet, and it doesn't whine at all now. And then you kind of bend the windings around until it's quiet, and then you leave it be, and then you glue it in place right there, and then don't touch it until your glue sets up. So the relays clicked in. As you can see, we have a bank here of 4 relays, one for each output. And I do have a red light here, glowing nice and red. And I have my 50 hertz signal coming in. And you'll see on the upper left-hand corner there, I do have the scope going for you guys. So there's my 50 hertz at 9 volts RMS. 50 hertz at 9 volts RMS. And here we're about 1.4 volts below the reference. And of course here we have the 9.4 volts RMS. So as you can see, we have one dead channel here. Yep, not functional. So I'm going to go ahead and turn it off. So from there, as you can see, what I do is I mark the terminal. I marked a little mark right here. You got to work your way back. And I've had some questions on how to go about tracing signals. Well, the easiest way to diagnose a Class AB amplifier, a multi-channel amplifier, is to find out which terminal you don't have a signal on and work your way back. It'll point you right exactly to the transistors where you should start. So let me just disconnect my power supply real quick here. And again, I want to be careful because I just glued my transformer down. Customers don't like it when you send their amplifiers back and then it whines. So I'm on this terminal right here by my thumb. So I'm going to flip it over. So this terminal here, so these amplifiers have a RC snubber, a resistor capacitor snubber that goes to ground. So this relay, let me get track of the relay. So this is this channel, this relay is this channel. Okay, so here's the snubber. This is the resistor going through the capacitor to ground. So here's the relay contacts right here. And if you follow this relay contact, it's this trace right here. And if you follow this trace back, you will find that this trace, just marking it out because it's kind of hard to see on this red background here. So that trace right here goes to this set of transistors. Again, this is a Class AB, so you're going to have emitter resistors in place, which are right here. And as you can see, I got my little black mark here. I was working on this board, and I've been doing a lot of procrastinating about shooting videos, so I just started working on this. I'm like, you know, I haven't done an MMats for my audience, so I figured I'd just go ahead and shoot a video on this before I got too far into the board. So it's these two transistors here that this terminal is bringing us to. So now what we're going to do is we're going to go ahead and turn the scope off. And I'm going to go ahead and bring you my meter. So we're going to do some measurements here. Let me shorten up the box here so it doesn't take up so much space. Connect the meter. All right. So these are the transistors we're working with that doesn't have a good output. So what I do is I take my meter and I'll check the neighboring transistors here. 2.3 mega ohms from base to emitter. And 2.1 mega ohms from base to collector. So let's jump on over to this set of transistors here that is coming bad from this terminal. So base to emitter, 4.4K. Now remember what the other reading was, we were in the mega ohms. And then base to collector, 4.2 ohms. So that's this transistor here. Let's check the one next to it. We're about 400, 500. Looks like it's charging some capacitance there. Base to emitter, and then we're going to go base to collector. Base to collector, 4.8 mega ohms. So let's go back to this transistor and check base to collector. And are we in the mega ohms? 2.5 mega ohms. So this transistor here has a short between the base and collector of 4.3 ohms. So that short from the base will actually come back through and it'll drag down your drivers that drive these transistors. It'll drag that down. It'll take that signal and just drag it down to ground, which that's what we were seeing at the output terminal on the scope, is that signal was being pulled down to that zero reference. Remember, this is a class AB, so you have positive rail and then negative rail with zero reference in between. So this transistor needs to come out. So I'm going to go ahead and flip it over while being careful not to move my transformer. And I'm going to go ahead and desolder this transistor. I'm going to move their Captain tape that the factory put on this to keep from shorting out the board, I guess, when it slides out, because this board slides in out of the heatsink. And I'm going to add some new solder to the transistor legs because, you know, the good old lead-free solder that they use, in my opinion, is complete garbage for what we do. Let me just peel this Captain tape up. I'll replace that when I'm done. And now let's put this good old Hacko, the old Hacko 301 here. Let's put that good old Hacko to use. This makes really quick work for desoldering transistors. Makes quick work for soldering transistors. Just quick and simple. No pulled vias, no damage to anything. Again, just quick and simple. So I'm going to take my meter and I'm going to read the transistor that was next to it again. Thermal paste. Can't stand thermal paste. So let me read this one again. 4K. Do believe this one's probably going to be damaged also, because I'm reading 4K. Right? Let me get the pins right. Oh no, that's that is collector to emitter. I'm getting 4K collector to emitter. Let me check collector emitter. Oh yeah, 4K, perfect. So the channel that works is 4K collector to emitter while charging the capacitors. So we're good. All right, so I pulled that bad transistor out, and let's actually see what this test says. If my assumption is right, it will come back as a shorted transistor. And more than likely, it'll free up the drive signal. So let me run my test real quick here. And there it is. 1 to 2 is shorted. Just like I was showing in circuit on my meter, I was showing a short from the base to collector. And the transistor tester just confirms that. Now, sometimes that short will damage the drivers. And in most cases, what I'll do is I will replace the drivers anyways, because all that current, well, Yeah, because it's base to collector. So your voltage, your rail voltage, shorts back through the base, comes back through your drivers, and it can just wreak havoc all the way back. It usually damages the drivers if the protection circuit doesn't catch it. So I'm just going to check the resistance of the drivers here real quick. $2.3K and 2.3K. So it actually looks like it may have survived, which isn't too bad. Again, sometimes on those shorts, it does damage components behind it. So let's see here. If I hook up a signal, am I going to get a base drive? It's probably not going to be very happy because I do still have a transistor installed. But I'm just going to check something here. I'm going to just turn my power back on real quick. And get my scope. I'm just checking. I haven't started my scope back up, but I'm just checking to see. Oh yeah. So I do have a good base drive on the base of this. And let me go ahead and turn off my meter. I can't run these both at the same time because my software hangs if I try to run the meter and the scope at the same time. So let me fire up this scope again for you guys, and I'll show you what I'm looking for. It's just a really quick example. Let me make sure I have a signal for you guys. Yep. All right. So let me fire this back up here and show you what I'm looking for. So I'm on the base pad of the transistor that I pulled out. And I'm just going to fire it up really brief here. And you can see that sine wave and it comes back up. So that is exactly what I'm looking for. So I'm still getting my drive signal from the drivers coming back to the base pad. And you can see where it's kind of wonky looking because obviously with the transistors out, so there's no feedback on that. But that's what I was looking for. So this is the MJL1302A. I don't have this. It may be equivalent to something like the 5200. Maybe. I'm going to have to dig into this. But otherwise, I just wanted to show you guys how I go about just quickly finding the problem, pulling the problem out, and then checking to see if it has cleared any issues in the driver section of the amplifier. So I do thank you guys for watching. Please leave your comments down below, like and subscribe if you'd like to. I see that my channel is growing. I do appreciate all of you that come on my channel, make comments, and subscribe to me. I have never imagined I would actually grow this big. So I do thank you again. Keep your fingers out of the rail voltage here. Stay safe. Catch you on the next one.